Bismillahirrahmanirrahim. Assalamu alaikum. Dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So now let's begin. Our today's lecture is typical reactivity of diazines, where we will take pyrimidine as an example. So talking about the typical reactivity, first of all, we see some of the general reactions of pyrimidine towards nucleophile and electrophile substitution reactions. So, first of all, we see the reaction of pyrimidine with a nucleophile, that is lithium alkyl or alkyl lithium. Here, the lithium is partially positively charged and the alkyl group acts as a carbanion, where it would have the partial negative charge. When this nucleophile would react with this pyrimidine, then first of all it would form a dihydroadduct. What is the dihydroadduct? That means, as you know, that here there is already one hydrogen, but there is no hydrogen. And in the case of this alkyl lithium, the alkyl group would react with this position, that is alpha to this nitrogen, or you may also react at this position. Let this species to react at alpha position either to this nitrogen or to this one. So here is the alkyl group and this hydrogen is here. And the other two double bonds are over here, and the one lithium here, it may accompany with this nitrogen, or you may also write down the hydrogen over here, because you know that water is also present in the reaction mixture, so we may take the hydrogen from the reaction mixture. So as you know that these two positions are hydrogenated, right? So owing to this reason, we call it dihydroadduct. And to get our final product as a result of reaction of this nucleophilic species with this pyrimidine, we will oxidize or aromatize this dihydroadduct and it would form here. There would be an alkyl group, the R. The alkyl group would be present over here, and this hydrogen would leave. This bond would be shifted here and this would be left in the form of H2. So H2 would be eliminated over here and the final product would be alpha substituted to the nitrogen. So as a result of this nucleophilic substitution reaction, we get this product where the alkyl group gets the position that is alpha to nitrogen. And what happens in the case where electrophilic species reacts with this pyrimidine? The electrophilic substitutions cannot be taken place. The electrophilic substitution reactions cannot take place unless any activating group is present over the pyrimidine or any diazine. Some activating species must be present or must be attached on the diazine. Only in that case these diazines would react with electrophilic substitution reactions. And what type of activating species must be present? For example, amino group, that is NH2 or oxygen. Okay, any activating species like amino group or oxygen must be present over the diazine to activate this diazine to react with electrophilic species. Then we move to the next reaction, that is with the proton. If this pyrimidine reacts with a proton, then the nitrogen lone pair would attract this proton to form like this one, and we will call it pyrimidinium salt or pyrimidinium cation. This would be pyrimidinium cation, and with some other species like alkyl halides or per acids, it would form quaternary salts. Like here, nitrogen is forming 4 bonds, so we will place the positive charge over this nitrogen. Here, one point is very important, that only one nitrogen among these 2 nitrogens would be protonated. Both of these nitrogen can never be protonated, because one positive charge on one nitrogen would make it less reactive towards any other protonation, because the electron density would become less because of this protocation. So next reaction is with methyl iodide, and we may say that the diazines form salts when they react with alkyl halides or per acids, that is RCO3H, where that means R group is attached with this carbonyl carbon, and this carbon is further attached with 2 oxygens and then with 1 hydrogen. So in this is the open air structure of this per acid. So diazines react with these alkyl halides and per acids to form N-alkyl quaternary salts. Same like here, the proton is attached with this nitrogen, so here it would form N-alkyl. That means the alkyl group or this methyl group is attached with this nitrogen, and it would form N-alkyl quaternary salts, because nitrogen is making 4 bonds over here, so that is why we call it the quaternary salts. And such type of reactions or electrophilic additions at nitrogen take place at only one nitrogen, not on the both of nitrogens. And in the case of per acid, it would form an oxide like this. Here it would be double bond. So in this case, it would form here there is a positive charge on the nitrogen, that is why we call them as quaternary salts, and this is the methyl salt of pyrimidinium ion, and this is N-oxide quaternary salt, or the other name is pyrimidine N-oxide. So its name is pyrimidine N-oxide. It is name of this compound, pyrimidine N-oxide, and this is called as methyl N-alkyl quaternary salt or methyl salt of pyrimidinium ion. So our next question is how unsubstituted diazines like this is also unsubstituted diazine. So these unsubstituted diazines respond towards electrophilic and nucleophilic substitution reactions. First we have seen their general reactions. Now theoretically we see that how these unsubstituted diazines respond towards electrophilic and nucleophilic substitution reactions. The answer is the diazines, any diazine, for example, that is pyridazine, pyrimidine and pyrazine, they contain two nitrogens like this, and in the case of pyrazine, this nitrogen would be at para position or 4 position, and in the case of pyridazine, this nitrogen would be at alpha position. So any of the diazine contains two imine nitrogen atoms. So here this nitrogen is called as imine nitrogen because it is doubly bonded along one side, and again here it is also attached with any other either carbon or nitrogen. So these nitrogens are called as imine nitrogens. So diazines contain two imine nitrogen atoms, while pyridine, the formula of pyridine is the pyridine contains only one imine nitrogen, that is like this. This is pyridine and these are diazines. As an example, this is pyrimidine. So diazines contain two nitrogen atoms and pyridine contains only one nitrogen in the form of imine nitrogens. In the diazines, two heteroatoms withdraw electron density from the ring carbons even more than one in pyridine. So these two nitrogens would withdraw the electron density even more than this one nitrogen in the case of pyridine, because here there are two nitrogens and both are withdrawing the electron density from these ring carbons, but here there is only one nitrogen and it is withdrawing the electron density from the ring carbons. Hence, the unsubstituted diazines are even more resistant to electrophilic substitutions than is the pyridine. And alternatively, this increased electron deficiency at the ring carbons makes the diazines more easily attacked by nucleophiles than the pyridine. So here there is the comparative study that because these two nitrogens withdraw the electron density from the ring carbons, so here the electron density would be less as compared to electron density in the pyridine. So when electron density is less, then obviously nucleophilic species may easily attack on the diazines as compared to pyridine, but electrophilic species are much more difficult to attack on these diazines as compared to pyridine. And hence the availability of nitrogen lone pair is also reduced. Yes, you have already seen that in the case of one protocation or in the case of when one nitrogen makes the quaternary salt, then the availability of the nitrogen lone pair on the other nitrogen is reduced, because two positive charges cannot make this compound stable. So that is the reason this only one nitrogen gets attacked, and hence each of the diazines is appreciably less basic than pyridine, reflecting the destabilizing influence of second nitrogen on an protocation. So thank you very much for watching the video. This is the end of our lecture. Please subscribe my channel and press bell icon. Allah Hafiz.